Hello dear students. So today's lecture is about that Legendre polynomial. We have already discussed it in previous. You just watch my previous video. So we have already talked about that the first recurrence relation that we get from that generative function of that Legendre polynomial, right? Because we know that जो हमारी generating function है for this Legendre polynomial, that is 1 minus 2x plus t square raised for minus 1 by 2 equal to summation n starts from 0 to infinity pn of x t raised for n. So that was basically our generating function. तो generating function से हम क्या करेंगे? We basically got first that recurrence relation, means the relation between the different coefficients of that p, that Legendre polynomial. So that was basically this thing. तो हमने ये कैसे मतलब ये जो हमारी first recurrence relation है, how we get that from this generating function? We basically differentiate this equation. तो हमने इसको differentiate किया है with respect to t. Right? तो जब इसको मैंने differentiate किया है with respect to t, I'm getting this recurrence relation. So you just visit my previous video. So I calculate this first recurrence relation after differentiating this equation, the generating function with respect to t. Now another recurrence relation. So this is, suppose this equation first here, and this equation first is our first recurrence relation for this Legendre polynomial. Now second is, if you again take this generating function, अगर हम generating function लेंगे and if I differentiate it with respect to, because we have two variables here, first is x and then t, right? Now if you differentiate this generating function with respect to t, right? So we differentiate this equation. So this is equation A. Now you differentiate A. तो इसको मैं with respect to t अब differentiate करूँगा. When I differentiate it, so okay, let's write first our this right hand side. तो जो right hand side है, because we need to differentiate it, sorry, with respect to x. So we need to differentiate it with respect to x here. Because this equation I'm getting when I differentiate the generating function with respect to t. Now you differentiate this equation A with respect to x now. So let us write our right hand side of this equation A. तो जब हम right hand side लिखेंगे, because we have this is a function of x here, so it will be p dash of x and it will be constant, right? So I can write this as that will be equal to, okay, because when you differentiate this, so this will be minus 1 by 2 raised power that n minus 1, so this will minus 3 by 2, and now you differentiate this part. तो जब हम इस part को differentiate करेंगे, because we need to differentiate it with respect to x, so it will be minus 2t and this will be constant here, right? Now you can rewrite this as, so this will be equal to t into 2xt. So that's our, okay. Now again, now you convert this, because I can write this as raised power minus 1 by 2 into this thing. So I can rewrite this as, because आप ये चेक कर सकते हो because it is 1 minus 2x t plus t square raised power minus 3 by 2. So and t is in the multiplication, तो t मैंने ऐसे रखा, t is this thing, and this इसको मैं रख सकता हूँ minus 1 by 2 and minus 1, that's minus 3 by 2. Huh? But this term, if you remember that, so this is our generating function. So that means 1 minus 2x t plus t square raised power minus 1 by 2 is that summation and starts from 0 to infinity n of x t raised power n. तो इसके बदले में लिख सकता हूँ, so this will be equal to that t summation and divide by, okay, so that's equal to, okay, or I can rewrite this as, okay, because so हमारा right hand side, because you can take into the multiplication when you multiplied to the left hand side of this equation, and on the right hand side because t is multiplied, so this will be t raised power n plus 1. Okay, because okay, now you can take, so you can take, you have three terms on the left hand side, because when you multiply that 1 minus 2x t plus t square to this whole term, so you will get three terms here, and so the first term will be here, so that will be summation. Okay, so just have a quick look on this. तो जो हमारा लेफ्ट हैंड साइड था, तो आई बेसिकली मल्टीप्लाई दैट वन टू दिस टर्म, तो पहली टर्म जो आएगी, so that will be p n dash of x t raised power n. Now this minus 2x will be as it is, and now t multiplied to this, so it will be p n dash of x t raised power n plus 1. And the third term from the left hand side will be that t square when you multiply to this term, so this will be p n dash of x t raised power n plus 2. As the right hand side will be same as it is. Now we can do one thing, so we can equate the coefficients of t raised power n. तो उस time हमें क्या करना है? We need to shift that here n to n minus 1, so it will be t raised power n, or you need to shift it n to n minus 2. So there are many ways, so how you can relate these different coefficients of that Legendre polynomial p's, right? So this finally gives us the recurrence. So there are many forms of these recurrence relation. Let us focus on the main those recurrence relation, so that I can get if you equate now. So better is to write now, because we will equate the coefficients of t raised power n plus 1 here. तो उसके लिए हमें क्या करना है, तो अगर हम राइट हैंड साइड अगर हम देखेंगे, तो ये जो टर्म है, तो इस टर्म के लिए हमें n को शिफ्ट करना है टू n minus n plus 1 इस टर्म के लिए, because when you shift n to n plus 1 to the first term on the left hand side, so this will be n plus 1 dash of x t raised power n plus 1, and similarly यहाँ पे ऑलरेडी t raised power n plus 1 है, no need to change this term, so ये term, this term will be as it is. Okay, so there was some problem. Okay, that's it. Now क्या यहाँ पे ऑलरेडी t raised power n plus है, n plus 1 है, बट फॉर द थर्ड टर्म, जो हमारी थर्ड टर्म है, थर्ड टर्म के लिए यहाँ पे है, तो ये आना चाहिए t raised power n plus 1. तो यहाँ पे हम शिफ्ट करेंगे, इस टर्म के लिए हम शिफ्ट करेंगे that n to n minus 1. So when I shift that n to n minus 1 here, so it will be p n minus 1 dash of x t raised power n plus 1 because I am shifting n to n minus 1. तो मुझे हर कोई जो कोएफिशिएंट यहाँ पे होगा t raised power it should be t raised power n plus 1. And similarly for this, तो no need to change this because यहाँ पे already t raised power n plus 1 है. तो दो टर्म्स में मुझे चेंज करना है. एक तो फर्स्ट टर्म जो है यहाँ पे मुझे शिफ्ट करना है n to n plus 1. And to the third term on the left hand side, so I need to change that n to n minus 1 here. So let us write the, so what will be our next step? So that will be equal to, so summation that, in addition to that, so let's have a look. So when I shift that n to n plus 1, so summation will go from minus 1 to infinity here, right? So it will be p n dash of x. And the next term will be, so that will be as it is. Here is for n plus 1. Just have a look because ये मैंने already लिखा है, that is 2x p n dash of x. तो इसमें हमें शिफ्ट करना है n to n minus 1. तो समेशन यहाँ पे जाएगा n equal to 1 to infinity and this will be p n plus 1. हाँ? Okay, because यहाँ पे मैंने जो शिफ्ट किया है, because I shift here n to n minus 1 here. Sorry, this is here minus. Okay, so this is the left hand side. तो जो हमारा राइट हैंड साइड है, तो राइट हैंड साइड में कोई चेंज नहीं आएगी बिकॉज यहाँ पे ऑलरेडी t raised पर n plus 1 है, so no need to shift that n, right? So the right hand side will be as it is. So right hand side will be equal to, okay. Now you can do one thing. Now you equate the coefficients. So you equate. Okay. So this will be equal to. Okay. Or you can let us. I can rewrite this as. Okay. So this is another reconciliation. So we have two reconciliation, or I can from these I can modify them. So I can because already we have one more reconciliation. Just have a look on this. So because this one, okay. So we have first reconciliation, that is 2n plus 1 x p n of x, right? That's equal to this thing. So we can do one thing. So we can add or we can multiply this. So we can do one thing. So we can multiply that 2n plus 1 to this 2. So 2n plus 1 इसको मैं ऐड करूंगा. So if I multiply here, or I can multiply here 2n plus 1 Inside will be that p dash of. Okay. So simply मैंने यहाँ पे 12 plus 1 add किया है. Now I can do one thing. So if I rewrite that term, okay, so you can write this as because I can use now equation first now. So from equation first, so because the equation first is that is this thing, that is 12 plus 1 x p n of x equal to n plus 1 plus this thing. Okay. So I can do one thing. I can differentiate this equation. Now you differentiate equation first, and then use in this equation, right? So let us differentiate it. Okay. So we can do one thing. So we can differentiate equation first now. So let us differentiate. So we have this equation. So from equation first, we have this 12 plus 1. Okay. Okay, that's it. Now you differentiate this equation with respect to x. Yeah? So when you differentiate this, you differentiate with respect to x. Okay. So this will be equal to. Okay. I simply differentiate this equation first. Now you use the previous equation now, right? Because so you just check. So what is pending there? So you can do one thing, or because in previous equation, just have a look. We can have. So यहाँ पे जो हमारे पास है that is 12 plus 1 pn of x. Okay, so 12 plus 1 pn of x plus 2x pn dash of x, right? So you can write this as. So instead of this, you can use this as because okay, you just do one thing, or you can do one because you can multiply here twice here because यहाँ पे already 2 है. Okay, so there is already 2, so you can write this as 2 into 12 plus 1, or you can write this as 2 into 12 plus 1 x plus x, yeah, dash of x. So that will be equal to. Okay. Now because अगर हम देखेंगे, अगर हम previous equation check करेंगे, तो previous equation में हमारे पास है that is twice pn of x plus 2x pn dash of x. But you just check here. तो हमारी जो ये equation है, so we have 2x here, 2x pn dash of x, but here is pn of x, right? तो हम क्या करेंगे? We can add now pn of x on both sides, right? तो जब मैं pn of x इस equation को add करूंगा, so when I add this equation, so that means I can rewrite this as okay. So what I'm doing here, okay. So ये हमारी जो equation है, so we can do one thing. or you can subtract this Pn of x to this term. Huh? So we can do one thing here. We can write this as this will be equal to that 2n plus 1 into 2x Pn of x plus 2x Pn dash. Right? So this is the left hand side and right hand side will be as it is. That's 2 into n plus 1 Pn plus 1. Okay, तो ये हमारा लेफ्ट हैंड साइड है. So that means हमें ये चीज चाहिए. So we need this thing, right? That is 2x Pn of x plus 2x Pn dash of x. तो हम ये यहाँ से यूज कर सकते हैं. So we can take it from here. Pn of x, so that is this thing. So Pn of x plus 2x Pn dash of x. तो मगर यहाँ पे so it should be twice Pn of x. So that means I can write now. I can add 2n plus 1 Pn of x to both these sides. तो अगर मैं इसको ऐड करूंगा इस वाली इक्वेशन को, तो लेट मी रीराइट दिस इक्वेशन वन मोर टाइम. So let's write one more time. That's 12 plus 1. तो ये हमारी ये इक्वेशन है. जस्ट हैव अ लुक. तो ये वाली हमारी ये इक्वेशन. That's 2n plus 1 Pn dash of x plus P dash of n minus 1 of x. That's 2n plus 1 Pn of x plus 2x Pn of x. तो ये हमारी ये इक्वेशन है. ओके. तो इसको मैं क्या करूंगा? I can add now 2n plus 1. I can add Pn of x. तो ये मुझे ऐड करना है Pn of x to both sides, right? तो उससे क्या होगा? तो जो हमारा लेफ्ट हैंड साइड होगा, so that is 12 plus 1. It will be that P dash of n plus 1 of x. Okay, sorry, I should write here one more time. So this is our left hand side. तो जो हमारा right hand side आएगा, that will be 12 plus 1. Okay. तो ये मैंने ऐड किया that 12 plus 1. जब 12 plus 1 मैं यहाँ पे ऐड करूंगा, तो that 12 plus 1 is ये already common है, तो यहाँ पे आएगा Pn of x and so it will be twice Pn of x. So twice Pn of x, already 12 plus 1 is already here, so this you can take out. Now we can use this. So instead of this, or you can write that. So because we have already that this 12 plus 1 Pn of x is equal to this thing. Okay, right? So I can use it in this equation. So that means इसके बदले में लिख सकता हूँ 2n plus 1 Pn dash of x plus 2x this thing, right? So that means I can write this as तो जो left hand side आएगा, so that will be equal to, okay, you can write this as 12 plus 1, huh? Okay. Okay, so you can write this as 2 into, that will be equal to, okay, so I need to use this term, huh? So that is 2x Pn of x plus 2x Pn dash of x into earlier equation. Or you can write this as that 2n plus 1, और इसको मैं ऐसे भी लिख सकता हूँ 2n plus 1 into Pn dash of n plus 1. So that will be equal to 2 into n plus 1. तो ये यहाँ पे क्या आएगा, बिकॉज तो इसके बदले जो आएगा ये, इसके बदले ये टर्म आएगी कौन सी, दैट इज 2 into that n plus 1 p dash of n plus 1 of x plus 2n p dash of n minus 1 of x, वही मैंने लिखा, because these will be equal, or you can write this as, because so if you equate this, compare this equation with the other equation, तो हमारे पास आएगा 2n plus 1, or you can write this as equation that x, and suppose this is equation y, so better is to write this way. So you can write this as from equation x. So in case, because left side of this equation x and equation y, these will be equal, right? So वही मैंने यहाँ पे लिखा. Now we can also modify it a bit, because we have this 2n plus 1 on the both sides, और इसको मैं लिख सकता हूँ. So यहाँ पे जो ये टर्म है, तो यहाँ पे 2n plus 1 है, p dash of n, यहाँ पे 2n plus 2 है, because this 2n plus 2, right? तो अगर मैं ये टर्म और ये टर्म लूंगा, पहली वाली टर्म, तो यहाँ पे 2n plus 2 है, this is 2n plus 2, so this is 2n plus 1. If I take it on the right hand side, so it will be 2n plus 2 minus 2n minus 1. So it will be simply that p dash of n plus 1 of x, right? So that means जो हमारी first term आएगी, that will be p dash of n plus 1 of x, right? Because ये है 2n plus 1, so this is 2n plus 2 here, right? तो इसको मैं लिख सकता हूँ ना 2n plus 2. तो अगर मैं इसको सब्ट्रैक्ट करूंगा, when I take it on the right hand side, तो ये आएगा minus 2n minus 1, so it will be, so 2n cancel, it will be 2 minus 1 p dash of n plus 1 of x. तो वही मैंने लिखा, फर्स्ट टर्म जो आएगी, that is p dash of n plus 1 of x, right? Now the second term, तो second term यहाँ पे है, that is p dash of n minus 1 of x, but multiplied that 2n plus 1. So if I take it on the right hand side, तो यहाँ पे already 2n है, right? तो ये आएगा 2n minus 2n minus 1, right? तो ये टर्म क्या आएगी, तो वो टर्म आएगी, तो दिस इज 2n plus 1, तो यहाँ पे 2n है, right? So that means it comes out to be 2n minus 2n minus 1. So 2n will cancel, so it will be minus p dash of n minus 1 of x. So second term will be minus, right? Okay. So this was our राइट हैंड साइड. जब मैंने ये दो टर्म्स कहाँ से ली, टुवर्ड्स माय लेफ्ट हैंड, टुवर्ड्स माय राइट हैंड साइड. तो लेफ्ट हैंड साइड में क्या रहा, लेफ्ट हैंड साइड में रहा 2n plus 1 एंड दिस टर्म, दैट्स 2n plus pn of x. तो दैट मींस जो हमारा लेफ्ट हैंड साइड रहा, दैट इज 2n plus 1. So this is the third recurrence relation that I am getting by manipulating, by differentiating equation. First recurrence relation, then add by multiplied by factor 2, and also multiplying 2n plus 1 to my second recurrence relation, and then comparing those two equations, those two recurrence relations, and I am getting the third recurrence relation, right? Now I have, this is our third recurrence relation. Now let us check our second recurrence relation. So our second recurrence relation is, that is this one. What is that? So that is p dash of n plus 1 of x plus p dash of n minus 1 of x. That is pn of x plus 2x pn dash of x. तो इसको मैं लिख सकता हूँ, I can write it here. That is p dash of, so that will be equal to, वो किसके बराबर आएगा, so that is here. तो जो हमारा राइट हैंड साइड है, so that is pn of x plus 2x pn dash of x. pn of x 2x p and dash of x, right? That's correct. So ये हमारी second. So this is third recurrence relation, and this is our second recurrence relation, right? Right. So these are, so I'm basically putting that equation 2 here because this is our second recurrence relation, and the top one is our third recurrence relation, right? Now I can get some more by manipulating or by adding or subtracting. I get some more recurrence relation. So if you add these equations, तो अगर मैं इनको add करूँगा, so I will get that twice that will be equal to. So what should I get on the right hand side? So this is 2n plus 1 pn of x, this is pn of x. So this will be 2n plus 2. Or you can write that. Okay. Because you can take that 2 common and that will cancel on the both sides. Because you can take that 2 common from here, it will be n plus 1 pn of x plus x pn dash of x. And the right hand side will be that p dash of n plus 1 because 2 cancel हो जाएगा दोनों side से, so it will be this term. Huh? So this is our fourth recurrence relation. Now I can get one more relation if you subtract them. So if you subtract these two relations, if you subtract, so what should I get here? So if I subtract, if I write this minus this, means I'm subtracting third from second, right? So यहाँ पे क्या आएगा? So I'm subtracting third from second. Okay. So I should get here twice that p dash of n minus 1 of x. Okay. Because this minus this, and here यहाँ पे क्या आएगा? That is pn of x minus this term. So add this term. So ये आएगा क्या? So this should be equal to that is twice x pn dash of x, and now minus that 2n pn of x, राइट? क्योंकि यहाँ पे हमें क्या करना है, pn of x minus 2n minus 1 pn of x. तो एक pn of x कैंसिल हो जाएगा, तो ये आ जाएगा minus 2 pn of x, and this will be 2x because we need to subtract third from second. So it will be that 2x pn dash of x. Now 2 common है, so 2 is common on the both sides, so you can cancel that, huh? Or you can write this as you can write this. So this is our fifth recurrence. So these are, so you can get some more reconciliation by manipulating or by taking different ways to get some more relation between the different coefficients of that Legendre polynomial. So okay, so I think this will be enough for today's lecture, and in our next lecture we are going to discuss about that orthogonality and the normalization condition in case of this Legendre, that differential equation or Legendre polynomial. And so let us see so how much we can complete. So hopefully you will get this. If there will be some problem related to this today's lecture or previous lectures, so you can write it in the comment if there is some confusion at some point. So let me know, I will try to clarify that. Thank you very much.